Across this small gap, an enormous voltage is being applied. Glowing arcs appear like tiny lightning strikes. Then, a blinding light and an incredible heat. Plasma. What you're seeing is hotter than the surface of the sun and too bright to look directly at. It's hot enough to melt hafnium carbonitride, the substance with the highest melting point known to science. But more importantly, this plasma is stable and uniform across a wide area, and that has never been achieved before. The new method could change the way that certain materials are made and revolutionise high-temperature material physics. If you want to create extreme heat, making a plasma is a good way to go about it. Plasma is a strange substance, known as the fourth state of matter after solid, liquid and gas. It's a flowing mass of charged particles that can be incredibly hot, and it's actually not that hard to make. If you apply a large enough voltage across a gas, the electrons can separate from their atoms and start to flow across the voltage gap. The gas becomes ionized, and the rapidly moving charged particles emit heat and light. Think of it like a lightning strike, except instead of discharging all that power, engineers can keep the current flowing and use the heat that it's creating. This is what's happening inside a plasma cutter or in plasma arc welding. But the researchers behind this new system wanted to be able to create more than a single dancing lightning-like arc. Their new design is all about creating as stable a plasma as possible. It works by applying a voltage between these hairy-looking blocks made of thin carbon fibres. Each of these microscopic carbon hairs acts as a tip through which electrons can flow, and with so many hairs close together, all of the gas between the blocks, argon in this case, turns into plasma, at stable, uniform temperatures of up to nearly 8,000 degrees Celsius. These are the kinds of environments used to make certain materials, for example for jet engine turbine blades, which have to endure extreme forces at high temperatures. This new process could replace existing methods for mass-producing these materials. These are also the kinds of temperatures used by specialist physics labs to create and experiment with new kinds of materials. Only now, the researchers behind this work say, you won't need extremely specialist kit anymore, as their new design can be easily recreated in labs all around the world. And that could mean a lot more experimentation with extremely high temperature materials made using plasma.